let's knock out this geometry quiz review. All right, first let's name this plane. If it has a script letter on the plane and there's no point next to it, you can just call it that letter. So we can call it plane K, or you can call it plane and any three letters that are on here except for the ones that are collinear. So I can't use these three because they're on the same line, but I can use any other three. Because if I choose the three that are on there that are collinear, it doesn't make it unique. So I gotta pick three basically scattered letters. So I could call it plane X, W, U, or plane U, Z, T, or any other three, but I can't use X, W, and Z because they're collinear. Since I've already said that, name three collinear points. There they are. X, W, Z. And those are points that are together on the same line. They're coexisting on the same line, they're cohabitating the same line. Collinear means that they're together on the same line. Name three coplanar points. I can pick any three that are on there. X, Y, T. I can use other ones too, like W, Z, U. Name array. Array needs to have an arrow at the end on one end, so I can go WZ. Array WZ. I can do WX. I can't use WY because it doesn't keep going, so that's a segment, so I can't use that. I can use WU. I could also go the other direction. I can go ZW, keeps going on. That's array in that direction. I can pick XZ. And I could continue, basically anything that has an arrow at the end and 2 points. So let's see, WZ is in there, XZ is in there, ZX is in there. I can go ZX that way, ZX, because the direction is important. All right, name a line. I have this line right here. That's the only line on there with the arrows going in both directions, but I can call it a couple different things. I can call it XZ. I need to put two arrows above. I can call it WZ, arrows above, XW, arrows above. I can also switch the letters around on this one, so I can go WX, ZW, or ZX. WX, ZW, ZX. Arrows in both directions. Name a segment. I can basically take every single thing I wrote above, but take the arrows off, and those are segments. So XZ, WZ, XW, WX, ZW, ZX. I can also use YW now, or if you'd rather, WY. So if this was a quiz, I'd give you 1 point a piece for those. All right, next question. Here I got some segment addition going on. That's AB plus BC equals AC. So this part plus this part equals the whole part, and that's what I'm asking for there, is the length of that. So AB is just 5. BC is 27. And that equals the whole thing, AC. So 5 plus 27 is 32. And that gives me the length of AC. And if this were a quiz, I'd give you 2 points for that. The next question is using the same idea, using segment addition. Part plus the part equals the whole. So part, whole. So that's RS plus ST equals RT. And so I've got RS is 4x minus 10 plus ST is 2x. That equals the whole thing, RT, which is 38. I'm going to combine like terms. So 4x plus 2x is 6x. I've still got that minus 10 equals 38. I need to get the x by itself. So I need to get rid of this minus 10. I need to use the opposite operation. So I need to add 10 to both sides. Now I've got, bring down the 6x equals 38 plus 10 is 48. I still need to isolate this x. This is 6x, or 6 times x. So the opposite of times or multiplication is division. So I'm going to divide by 6 on both sides. And I get x equals 48 divided by 6, which is 8. I'm only partway through because I've solved for x. I've done a lot of algebra, which is good, but this is asking for the lengths of RS and ST, so I need to plug this back in to each one of these. So if I take x equals 8 and plug it into, let's see, RS is 4x minus 10, and I know x equals 8, but 4 times 8 minus 10 equals 4 times 8, which is 32, minus 10. That equals 22. And I just found RS. Now I need to plug in x for the other ST, the other length that I need, as for ST. So I need to plug into 2x. So ST is 2x. And I know that x equals 8. So I've got 2 times 8 is going to give me ST. And I know that equals 16. So I've got my two parts. I'd give you 3 points for this whole problem here. Basically, it's 1 point for that one, 1 point for that one, and did you solve for x along the way? If you show your work, I can give you some partial points. If not, I'm not able to. All right, for this next problem, there's a couple different ways to solve it. Let's start with using our midpoint formula. So I've got x1 plus x2 divided by 2 will give me my x value, and y1 plus y2 over 2 will give me my y value. So I know that the endpoints on here are 3, negative 4. So 1, 2, 3, negative 4. 1, 2, 3, 4. So that's 3, negative 4. And then I've got t, which is negative 1 up 2. And that's t. So somewhere here should be my midpoint. So using my formula, I'm just going to plug in my x values and my y values. So my x value for x1 is, I guess we can just decide. So x1, y1, x2, y2. So my x1 is 3. My x2 is negative 1. Those are my x values. Then switch to y values. My y1 is -4. And my y2 value is 2. So now I have 3 plus -1. So that's the same as 3 minus 1. That gives me 2 divided by 2. And then -4 plus 2 gives me -2 over 2. If I simplify that, I get 2 divided by 2 is 1, and -2 divided by 2 is -1. There's my midpoint. Also, what I could do, I could count the full length and then cut it in half. So if I count in the y direction, if I'm going from, let's go the x direction first. So if I go from this point to this point, I would need to count over 1, 2, 3, 4. So I have to count over 4, and half of 4 gives me 2. So if I just went 1, 2, somewhere along here is going to be my midpoint. And then the y value, counting down, 1, 2, 3, 4, 5, 6 is the full length. If I cut that in half to find the middle, I needed to count down 3. So 1, 2, 3. So where they cross is going to be my midpoint right there. And what is the coordinates, or what are the coordinates for that midpoint? Well, from the origin, 1 in the positive direction gives me 1 for the x value, and then I go down 1. So that is 1, -1. So it's the exact same thing, either way. And for a quiz, I'm going to give you 3 points for this. For either way. You don't need to do both. Pick your favorite. Do that way. Number 10. Number 10 I think is the trickiest on here. If I use my midpoint formula, just abbreviate real quick. I've got x1 plus x2 over 2 and y1 plus y2 over 2. When I use this, this tells me the x value of my midpoint. When I use this side, that tells me the y value of my midpoint. So I'm going to use ym. The m stands for midpoint. So I'll use purple still. One endpoint of AC is 5, 3. So that's one of my points. So I'm going to call that y1, x1. And its midpoint is 3, 2. So that's my midpoint x value, and that's my y value of the midpoint. So this feels like the answer's here. Not one of these, but the answer on the end. So if I use that, I get a slightly different equation here. So using x1 is 5 plus something I don't know over 2 equals the x value of my midpoint, which is 3. If I continue to solve, I'm dividing this whole thing by 2, and the way to get rid of dividing by 2 is multiplying by 2, so the opposite operation, and I need to do that on both sides. I can't do it on just one. So nicely, that cancels out, and I just have what's on top now. 5 plus x2 equals 3 times 2, which is 6. Getting the x by itself, I'm going to divide by 5, and I get this x value equals 1. If I go to the y side, my y1 is 3 plus y2 all over 2, and the y value of my midpoint is 2. So doing the same thing I did over here, I need to get rid of this dividing by 2. So I'm going to multiply the whole thing by 2. And I have to do that on both sides. So that these cancel out, and I just get what's on the top, which is 3 plus y2 equals 2 times 2, which is 4. I still need to get the y by itself, so I'm going to subtract 3. And I get y2 equals 4 minus 3, which is 1. So this is my other point, 1, comma 1. So when I combine them, 1, comma 1. There we go. If I wanted to use the graphing method, then I need to graph my endpoint, which is 5, comma 3. 1, 2, 3, 4, 5. 1, 2, 3. It's right there. That's my A. My midpoint is 3, comma 2. 1, 2, 3, up to 1, 2. That's my midpoint. And then I need to find out C. It's down here somewhere. I can tell, but I don't know where. So I need to count. So if I count down from A to M, count down 1, and then count over, looks like 2, then I need to do the exact same thing to find the other point, because it's right in the middle. So I'm going to count down 1 over 2, and I should be at my other point. That is red. And that is point C. So what is that point? From the origin, that's over 1. So a positive x, 1, and then going up, that's 1. So that's 1, comma 1. So I got the exact same answer using 2 different techniques. You can pick your favorite one. For this one, personally, I like the counting on the graph. On the first example with midpoints, I probably like the formula better. All right. Now find the distance between 2 points. First, let's write down the distance formula. The more that you write it down, the more likely you are to memorize it. I like to start with that. I've got the squares, I got the plus in the middle. I know that there are minuses in between. And I got the x values together, and I've got the y values together. So there's my distance formula, which really doesn't look different than the Pythagorean theorem, which I could also use. So if this is my x1, y1, this is my x2, y2. I'm just going to plug those into the equation and see what I get. So I don't make mistakes, I'm going to start off with that same method of writing down the formula as before, add those negative signs in. Now I'm going to plug in those points. And be careful of negatives. So I got x2. x2 is 1. I already had the minus there. x1 over here is 5. Okay. y2 is negative 2. And y1 is 1. So now if I continue, square root, parentheses, plus parentheses. I know I'm going to reduce them a little bit. So what is 1 minus 5? That is negative 4 squared. Now I've got negative 2 minus 1. Got to be careful on this one. That's negative 3. All of it squared. So I got the square root of negative 4 squared is 16, plus negative 3 squared is 9. So be careful with these. It's the parentheses is a negative 4 on the inside of those parentheses squared. That means it's negative 4 times negative 4, so it ends up being positive. Parentheses around this squared means it's negative 3 times negative 3, which is a positive 9. Then once I add those together, I get the square root of 25. That tells me that my distance all the way down, now that I've solved, is 5. So my distance is 5. if I plotted these points over here and did 5, 1, 5, 1, and then I did, that's point S, and point T is 1, negative 2, that's T, then I could use the Pythagorean theorem to find my hypotenuse. So I would just count, what's this length? 1, 2, 3, 4. This length is 1, 2, 3. And I gotta figure out what my hypotenuse is, which is really just my distance. So if I plug 4 into the Pythagorean theorem, I'll have 4 squared plus 3 squared, and that equals my c squared, or my distance across. So then I get 16 plus 9 equals c squared. I'm kind of running out of room there. Got 25 equals c squared. And if I square root, sure enough, I also get that my distance, or my hypotenuse, is 5. All right. For number 12 through 14, I need to identify the bisector. Well, point M cuts this in half. How do I know it cuts it in half? I've got those 2 tally marks right here. That means that this is congruent to this one. M is the bisector, so point M cuts it in half. But also, this fancy line cuts it in half. So I could also write line fancy M. Either one of those would work. I guess I just shared it, but if point M is in the middle of these two, M is the midpoint of LO. So I'm looking for midpoint. If you got those right, that's 1 point apiece. And then I forgot to write this above, but this one would be worth 3. Last part is finding LM and O. This problem can get confused with this one, where we're using segment addition, where we have a part plus a part equals a whole. However, on this one, I don't know how long the whole length is. It's not given to me, but I know that this one is the same as this one. I know that this segment is congruent to this segment. So I know the length of this one is equal to this one. So I can just set them equal to each other. This one equals that one. So I've got 2x plus 8 equals 4x minus 6. Those are the same lengths. So now I can use some algebra to solve for it. I'm going to subtract 4x from both sides to get the x's on one side. So I get negative 2x, bring down that 8, plus 8 equals that negative 6. I'm going to subtract 8 from both sides so I can get the x by itself. Get negative 2x equals negative 14. And now that I divide by negative 2 on both sides, I nicely get x equals 7. Algebraically, it feels like we're done, but in geometry, we have to plug it back in to find that length. So I'm going to take 2x plus 8. I'm going to put in x equals 7 for it, and that will tell me LM. So 2 times 7 plus 8. 2 times 7 is 14, plus 8 equals 22 for LM. Then I have MO. Wait a second. If those are the same, I just found MO. It's the same length, right? MO should also equal 22. Okay, well, what if I forgot that? Then let me just plug it back in to make sure. 4x minus 6. I know that x equals 7, so 4 times 7 minus 6. 4 times 7 is 28. Minus that 6. Sure enough, I found out that MO equals 22. Now I don't need to stress that those are actually the same. They are. So you get 3 points for this one. 1 for finding X, 1 for finding the two others. And there's your quiz, or your quiz review. Good luck.